Alright guys, let's solve some examples. Now the first step would be, of course, to find the voltage before time t0. Now before time t0, the switch is in this position. So when you redraw the circuit, remember, you have to open circuit the capacitor part. So the voltage, the current, can only flow in this direction. So the voltage Vt for time t0 can be found using the voltage divider. Now after time t0, the switch is in this position, so you don't need to consider this part because no current can flow through here. So if you redraw the circuit would look something like this. Now if you perform KCL on this node right here, the equation you get is this. And if you simplify this equation, you get this equation. And I have shown you how to solve this. You can put all the VTs on your left side and all the constants on the right side, or you can just remember the fact that the solution to this equation always comes in this form. Now this is because the only function that preserves its own form when differentiated is the exponential function. So when you remember this fact, you can easily guess the solution to this problem. And we recall that the solution to this problem is the initial voltage times the exponential. And this tau corresponds to R times C, which in this case is 0.2. Another way to solve this problem is to simplify the circuit before you actually calculate everything. You can see from this picture that these two resistors are connected together in parallel. So if you redraw the circuit, you can simplify the circuit in this way. And if you perform the KCL on this node right here, you would get the same answer as this, only in a much easier way.